Alright, today we're going to be talking about the unit circle. You see it all the time in textbooks and class, and it comes in pretty handy on assignments and tests. But I'll be honest, when I first saw a picture of it, like you see drawn here, I was pretty confused. What is going on? Why are there lines and angles and points everywhere? People often say that you have to memorize a unit circle, which seems like a headache given how many numbers and squiggles there are on this thing. Here, I'll try to explain what the unit circle is, when and how to use it, and how to memorize it. Well, first, the big thing to keep in mind is that trigonometry, right, what you use the unit circle for, has to do with the measurement of triangles. And you might say, well, this is a circle. Where are the triangles? Well, we can make triangles out of each one of these, right? Let's say this one, right? Where we have a 30-degree angle here. I can just go like this, right? And I can form a triangle based on this with a height of 1/2 and a length of √3/2. Now you might be saying, well, why do I keep saying the unit circle? That's because it has a radius of 1. So that means that this long line here, right, this line has a length of 1. And we can repeat this process for any triangle here, right? If we were to drop this here, this triangle with the degree measure of 45 would have a height of √2/2 and a length of √2/2, right? So we're talking about triangles. And the neat thing about the unit circle is that it lets us take trigonometric functions of a wide variety of angles, right? Because let's say, okay, I want to take the sine of 30. What's the sine of 30? Well, we know the sine is the opposite side of the hypotenuse over the side of the hypotenuse, right? So it would be 1/2 over 1. Or 1/2. The neat thing about the unit circle is that all the y's, all the y values for this unit circle are the sines of those corresponding angles. So I can just look at this and say, okay, well, the sine of 45 degrees is √2/2. What about the x-coordinate? Well, if I take, let's say, the cosine of 30, that's the adjacent over the hypotenuse, or that's √3/2 over 1, or √3/2. So all the x-coordinates are the cosine of the hypotenuse. When if I want to find tangent? Well, tangent is just the y-coordinate over the x-coordinate. Hey, I have both the y-coordinate and the x-coordinate, so I can find the tangent for all of these angles listed. And that's the great thing about the unit circle. It lets us conveniently visualize and write down so many trigonometric function values, which is really, really helpful. In particular, it lets us find values of trigonometric functions that are greater than 90, right? Because in a normal triangle, right, the maximum we can have any one angle is less than 180, right? Since angles in a triangle sum to 180, we can't have, let's take the sine of 300 using a triangle. We can't have that. But we can have it using something like this, right? We can just, drop an angle right here, and all of a sudden we can take the sine or cosine or tangent of 220 degrees, a crazy high number that comes up a lot in problems that you would not be able to solve without the unit circle. But with all that said, why do we have all these little slashes, right? What are these? This is another big thing that you might see with the unit circle, and that's called radians. Radians are another unit of measuring angles, right? So just like you can say, an angle is 90 degrees, you can say, it's pi/2 radians. And the conversion factor, or how many degrees you need to get 1 radian, is 180 degrees equals pi radians. Now, you usually see them written like rad, or just radians, but usually rad. That's the notation. Of course, degrees, they have that little circle above it. So that's the conversion factor. So if we ever need to say, oh, let's say I have 270 degrees, what's that in radians, right? Well, 270 is 180 times 3 halves. So if I were to multiply this whole equation by 3 halves, I have 270 equals 3 halves pi, which is how many radians. So 270 degrees is 3 halves pi radians, right? Conversely, right, if I have, what's 2/3 radians in degrees, right? So what's 2/3 pi radians? Well, I know pi radians is 180, so what's 2/3 times 180? That is 120. So 2/3 pi radians is 120 degrees. That's how you would just convert from radians and degrees, because some problems may want you to answer in degrees and other ones want you to answer in radians. And it's important to be able to switch between them whenever you have to. All right, but now if we're actually memorizing the unit circle, the big challenge, the big weird thing, I have 2 tips. The first is kind of think about the process. Always think about the process. Think about how you're building those triangles, and we're doing the sine, and we're doing the cosine, and we're doing the tangent. That'll make it a lot more easy to understand, right? Instead of just being, it's a collection of points. Okay, the y coordinates are the sines of these angles, and the x coordinates are the cosines of these angles, right? Think about the process. And then realize that you only really have to memorize 3 points, and then of those 3 points, you only really have to memorize 3 values, right? 3 pi over 2, 1/2. Root 3 over 2, 1/2. Root 2 over 2, 1/2, root 3 over 2. Negative 1/2, root 3 over 2. Root 2 over 2, root 2 over 2, negative root 2 over 2. Negative root 3 over 2, 1/2, right? These values reoccur again and again and again, over and over and over and over again. They allow us to kind of do a little skip, right? So you only really have to memorize this top quadrant here, right? And then if you think about the context, you'll be able to figure out the negative signs, right? Because let's say, okay, I know the 30. That point would be root 3 over 2, 1/2, right? But if I'm doing, say, 210, right? Well, I know that both of my points are going to be, in the third axis, which is negative, right? So both of my points there are going to be negative. Or if I'm, at 330, right? Well, then my y coordinate is going to be negative, my x coordinate is going to be positive, right? And then if you want to make it even simpler, right? Root 2 over 2 always goes root 2 over 2, and it's right in the middle, right? So it's between these two. And then it always goes root 3, then 1/2, then up to 1/2, root 3. They always change position. So if you think about these as like the tops, right? It goes 1/2, root 3, then root 3, 1/2. Root 3, 1/2, 1/2, root 3. If you memorize that pattern, it'll really, really serve you well. It can make things really, really easy. Another thing that you can do to kind of, expedite the process is just think of these as triangles, right? So you might have learned about special triangles, right? The 30, 60, 90 triangle and the 45, 45, 90 triangle, right? And there, if I had an x and a 30, 60, 90 triangle, my other side would be x root 3 and then 2x. And then in here, the 45, 90 triangle, I have x, x, x root 2. So if I know, I'm taking the sine of 30, or the sine of 60, or the sine of 135, or the sine of 150, I'm going to be dealing with the 30, 60, 90 triangle, right? So I'll find the value that works for that, and I evaluate based on that. So I want to take the sine of 30, right? Well, the sine of 30 is going to be x over 2x, so that's 1/2 x. That's another way you can do it. If you prefer to do it that way, if you're more comfortable working with just triangles, you can do that way. But if you're comfortable just keeping with this pattern, and memorizing this one quadrant and then shifting it over as you have to, right? So if you go this side, okay, well then all my x's will become negative. And if I go down to here, all my y's are going to become negative. And if I go here, all my coordinates are going to become negative. If you're comfortable just memorizing this, doing the flipping, become really, really easy for you. And if you're absolutely stuck, your mind blanks, just try to draw out the unit circle, right? Remember, go 30, 45, 60. Okay, let's say I want to do, what's the sine of 240, right? So I'll go up into 180, and I'll say, okay, I have to go to 240. So that's another 60 degrees, right? It's another 60 degrees. So if I were to drop my triangle, I would have an angle right here of 60 degrees. So what I'm really finding is the sine or the cosine of a 60-degree triangle. So I'll just remember my 60-degree point, or if I don't remember my 60-degree point, I can just use my 30, 60, 90 triangle and manually take the sine or cosine using the points, and I'll have my answer. And that's how you do and deal with the unit circle. I hope you enjoyed, and I hope you found it helpful. Have a great day.